right. So I just want to thank everyone for taking the time to join tonight. I know your time is valuable, and so I do appreciate when you take the time to join these. Uh, for those who might be new, the SoCal Cisco Users Group has been around for almost uh, 25 years. Will be 25 in July, and thank you, Tiago. And So we've been around for almost 25 years. It's always been led by engineers just trying to share information with other engineers. That's really kind of the mission statement of the whole group. So as I always do, I will ask if you know other people who you think might benefit from this kind of content, or if you have particular topics you'd like to see covered, please do share that with me. You can just pop it into the chat. You can also always email me. My email is at the bottom of the slides. Um, the slides and the recording will be provided to everyone uh, after the presentation. I'll send the slides out probably tomorrow. The recording always lands on YouTube between 3 and 5 days after the event, right? So I upload it to YouTube almost immediately, like tomorrow morning. But then our marketing department goes in and puts the intro and the outro and the search engine optimization tags and I don't know, whatever marketing people do. And and so you can expect the recording to be available in 3 to 5 days. So, and if you're not familiar with our YouTube channel, we record almost all of our meetings. We don't record ones where we do like live labs because there's not much to record. So feel free to peruse there. We've got past topics going back a couple of years even. That being said, tonight we're going to be covering practical OSPF for network engineers. And by practical, I really mean, well, we're going to cover things that might help you get a cert. I'm not really interested in teaching to a cert, right? So you'll see, like, for example, in the underpinnings of OSPF, we're going to cover things like LSA types. You could definitely expect that to be on a cert, but I don't cover them, you know, in depth for every type of LSA. I cover the LSAs I find to be most critical, and I cover why I find them to be so critical. So it's not a bad thing. It's not like I'm hurting your chances to cert up, but the user group has never really been about helping, or teaching certifications, I suppose. So let's just start with some terminology, basic terminology. And these are all specific to OSPF, even though these terms may apply to other protocols like autonomous system. But in OSPF, an autonomous system is basically a group of routers under a single common administrative domain. Basically, you or your company and your colleagues, what are the OSPF routers that you manage, right? That's what we mean by an autonomous system. Very similar to what we mean by an autonomous system in BGP, for example, right? Uh, although there is some differences, and we'll get into those with process ID or PID. This is the router process number, and it's important to keep in mind it is not the autonomous system, right? And in fact, in OSPF, there is no concept of an autonomous system number. There's just the autonomous system, and this is a difference between OSPF and BGP. I do know sometimes I'm working with clients and they will mention something like, oh, OSPF 100, so this is an autonomous system 100, but I see that this other router over here is running OSPF 10, so I guess I have two autonomous systems. No, it's a single autonomous system. You have two process IDs. By the way, you can have different process IDs on your OSPF routers. They will still form adjacencies, pass routes, everything else. It's not recommended though, just because of the confusion operationally, right? Everything should be more or less as cookie cutter as is reasonable. Area. So an area is just a logical numerical designation for routers in a common space or location or place in the network. We're going to talk a lot about areas tonight. So at the end, you should understand what an area is pretty well. I will also mention here, I'll take a quick break to say, along with the slides this month, I'm going to send out uh, an OSPF challenge. If you're interested, no one has to do it. I'm not grading your homework or anything, but it has like 17 or 18 written or multi-choice questions, and then it has a lab with, anywhere from a couple of hours to uh, maybe quite a few hours, depending on your skill set and background with OSPF. You would have to have your own ability to do that lab. I can't help you there, but if you have something like access to Cisco modeling labs, um, which you can get access to just on DevNet or developer.cisco.com, I think they only give you 4 hours per go. But once you get used to how to save and load um, YAML files, you can do a lot in those 4 hours. Trust me. And you don't have to lose your progress because you can just save everything off to a YAML file before you finish, keep it local, and then schedule another 4 hour session and load that YAML file, and you'll start right where you left off. So a backbone area is basically area zero. So area zero is an important area. You could probably guess that because it's called the backbone. Um, all other areas in OSPF must transit area zero or the backbone to speak to one another. So if I have an area zero, an area one, and an area two, for devices in area one to talk to devices in area two, they must do so through area zero. Area zero needs to be resilient, contiguous. There should be no single points of failure, for example, in area zero. Ideally, I totally get that we're constrained sometimes by the reality of where we're working or what our budgets are and so forth. But ideally, you want no single points of failure, good bandwidth. It doesn't have to be high bandwidth, but you don't want your LSAs getting choked out or anything like that in the backbone area in particular. And it does need to be contiguous. Now, anytime I say something must or has to, it's with an asterisk. I have had non-contiguous area zeros and made them work, but it's not ideal. And I have connected like an area one to an area two to an area zero so that area one transits area two to get to area zero. But again, it's not ideal. So when I say you have to or you must or it's like this or you always want to do this, it's with an asterisk. There might be a way around that, but it's just recommended. An area router is any router where all of its interfaces are in a single area, whether that's area 1 or 2 or 10 or 33 or whatever. An area border router uh, is a router who has interfaces in more than a single area, one of which is pretty much always area 0, right? Just by definition. If I'm connected to area 1 and area 2, I'm almost certainly also connected to area 0 because 1 and 2 can't talk to each other unless they can transit area 0, right? And that's an area border router. Its interfaces are in more than a single area, one of which is typically area 0. And then an autonomous system boundary router, or ASB, where we reach outside of OSPF system into the autonomous system. So maybe I have static routes, like a static default, and I redistribute that into OSPF or something like that. If I do that, that makes that router where the redistribution is done an ASBR. And we're going to talk a lot about ABRs and ASBRs because they're very important routers within OSPF. Any questions yet? Okay. Oops. So let's talk about just the very, very basics. It's called OSPF, Open Shortest Path First. What is shortest path first? Well, it's an algorithm. The thing to be aware of is that OSPF is called a state compared to, say, EIGRP, which is a distance vector protocol, um, uh, or BGP, which is a path vector protocol, for example. But OSPF is a link state protocol. This means that within an area, every router basically makes a map of all the other routers and their networks and puts itself kind of at the root of what we call the tree, right? And runs an algorithm to say, okay, here are all my paths to all my destinations, all the different networks I could reach within my area, not through the whole network, just for your area. And um, so uh, what's my best options? This SPF algorithm is also called the Dijkstra algorithm, comes to us via computer science, actually. And it's used to calculate the cost to get to every one of these networks. So for example, if there's just one network on each of these routers in the upper right, and R1 is trying to get the R5's network, for example, the Dijkstra tree or the SPF tree might look like this diagram on the lower left, where R1 puts itself at the root of the tree and builds its map. And it says, oh, I could get the R5 through R2, I could get there through R3, and I could get there through R4. What is the respective cost of each? And it says, well, look, getting to R5 through R2 is really bad. It's twice to get from R1 to R2 is twice the cost as to get from R1 to R3, for example, right? And R3 to R5 is half the cost or even a quarter of the cost uh, to get to R5. So you can see that it says, hey, the shortest path first, meaning it's going to take that path first. The shortest path is R1 to R3 to R5. Let's talk about that cost. The metric that creates the cost is basically based on bandwidth, but there's a huge limitation in OSPF that we're going to talk about right away, which is this concept of bandwidth. OSPF, this is just, it feels criminal to say this, still to this day, it bases its metric off of 100 megabit per second for the maximum bandwidth. This means if I have 100 meg or 500 meg or a gig or 10 gig or 40 gig, they're all just 100 meg from a metric perspective. They're all going to have a metric of 1. If I have a 100 meg link, it has a metric of 1. If I have a 100 gig link, it has a metric of 1, right? Which just doesn't make a lot of sense in modern day. So one of my first recommendations to people is when you're dealing with OSPF is change that reference bandwidth and change it to something big. I would say, personally, I would change it to 100 gig. You can change it up to, I think, 4 terabits, sorry, per second. But I typically do it at 100 gig these days. Because most people are not routing across 100 gig networks, but 100 gig networks are starting to become a little more common on our campuses. I should also point out, while I say that it's based on 100 meg for the reference bandwidth, there are exceptions. I believe that maybe the iOS 9000, which runs not iOS, but iOS XR, code, I think, has changed that reference bandwidth. And I think some of the Nexus switches for the data center have changed that bandwidth, reference bandwidth a little bit. Also, when you do change the reference bandwidth, you need to change it everywhere in the autonomous system. You can start at each area, as you're going to see when we get into defining our areas and building out our areas. It definitely, you want it to agree within an area, but it's a best practice to agree across the entire autonomous system, right? So hopefully that makes some sense. It's a big thing I try to recommend to people because these days, especially in even a decent sized enterprise, getting a 100 meg WAN link isn't that hard, and having 1 gig or 10 gig in your campus is really easy. And 1 gig's really the minimum. That's kind of living in the past. Most people are doing 10 gig. these days, and 10 gig tends to be about the same price as 40 gig. So now you see a lot of people in their campuses doing 40 gig or their data centers. So I really recommend changing that reference bandwidth so that OSPF can properly cost out the network. You could also, I wouldn't recommend it, but you could also just manually put a cost on all the interfaces so that you manually zip around the 100 meg limit. That seems awfully manual to me. I wouldn't be a fan of that. I'd rather change the auto cost reference bandwidth. OSPF in a single area is exactly what it sounds like, right? Not a lot to say here, but it means all the routers and all their interfaces are all in a single area. If you are going to run single area OSPF, I would recommend you always make it area 0. Why? Because if you're to the point where you needed to add another area, then you would have to create an area 0 anyway. Because remember, areas can only talk to one another through area 0. So if you do run single area OSPF, I'd always recommend to make it area 0. Hopefully that makes sense. Multi-area OSPF is, in my experience, much more common. Remember that OSPF is always running per interface, so each interface belongs to exactly one area. If we look at R1, R1 has an interface that belongs to area 13 and an interface that belongs to area 0, right? So by the way, that by default or by definition makes it an ABR or area border router, right? Which makes sense. It just, if you think about it, right? It borders multiple areas, area border router, right? And remember what I mentioned at the very beginning, the SPF algorithm, it only runs per area. So I run the Dijkstra algorithm in area 13. I run a different Dijkstra algorithm in area 0, and a different Dijkstra algorithm in area 24. And all the routers in area 3 build a map based on the link state process. All the routers in area 0 do, or interfaces, I should say, not routers, interfaces. And all the interfaces in area 24 likewise do that. Routing between the areas is much more distance vector like, which again makes a lot more sense because if we really think about it, when area 13 wants to route somewhere, what does it do? It has to go to its ABR because its only option is to route across area 0, right? So it will be distance vector when it goes to exit, and it uses as the distance is based on the distance of the ABR, and the vector is the direction of the ABR, right? Now, it's not a distance vector protocol at all because what happens at R1? Well, R1 has a second map. It has a second link state map, and it says, oh, I've also got a full map for area 0. Let me put myself at the root and find out where you're going, and it will link state its way through area 0, right? But transiting between the areas is a little more distance vectory. Hopefully that made sense. If it doesn't, I wouldn't stress over it too much. Let's talk about the different network types. There are many different network types, but there's only two you really need to be worried about, and that's point-to-point and broadcast. This is because almost everything handed off these days is an Ethernet link, whether it's a WAN link or a LAN link. It's almost always just an Ethernet interface that you're plugging into. The OSPF network type is based on the physical media of the interface. And so an Ethernet interface, for example, is always going to be a broadcast interface. However, you could definitely have a situation where you're really more point to point and we're going to have another slide in a second where I go into this a little more. I would recommend manually changing the network type to point on those, and we'll go through why in a second. So just remember that the network type in OSPF is determined, by default at least, determined by the physical media of the interface. So if you're an Ethernet interface, you're always going to be a broadcast interface. These network types control things like the hello and dead intervals. So it's best practice to match the network type between two routers that are going to be adjacent. Not all your routers in an area have to have the same network type, but if you're trying to build an adjacency between two routers in OSPF, ideally you want them in the same uh, network type configuration. Although you can work around that if you just tweak the timers as needed. Now, luckily for us, like I said, 99.9% of the time you only have two that you deal with, which are point-to-point and broadcast, and they actually use the same timers. So you don't have to worry too much about it. This can become an issue though when you do multi-vendor OSPF. Not every vendor agrees on the network types, and not every vendor agrees on the hello and dead intervals. So if you're trying to work in a multi-vendor environment, I've done this many times, really more times than I could count. You want to make sure that you understand the hello and dead intervals. Don't worry so much about the network types because there's a good chance those will not line up between, say, Cisco and Juniper or Cisco and HP or something like that. So instead, pay attention to the hello and dead intervals and you can manually set those and base that or set those to set your adjacency between the two vendors. In a broadcast network, by the way, because it is broadcast, we actually elect something called a designated router and a backup designated router. And all the other routers in that broadcast network, they only form adjacencies to those two routers. And this is just from an efficiency standpoint. I can send all my updates to the DR and the BDR, and they will multicast them out to the rest of the network. So let's talk a little more about point-to-point. Point-to-point is just two routers hooked up back-to-back. When we get into the lab in a few minutes, we're going to take a look at a point-to-point setup first. Okay? Um, and I recommend that if you are truly plugged in back-to-back like this, there could be an intermediary like a layer 2 switch, or this could be like via a GRE tunnel across the internet or something like that. But if your interface, remember OSPF is interface driven. If your interface is, on a /30 network, for example, or could be on a /30 network, I would recommend changing the network type to point-to-point. It takes the DR/BDR election out, which could cause some instability, particularly if you're peering with like a service provider, which doesn't happen a lot anymore. It still does happen occasionally. I've actually just migrated a customer uh, on a network like that where they were exchanging routes directly with their OSPF routes directly with their ISP. I wouldn't say you see that very often anymore, but it's still out there. I would always move those to point, even though remember it's probably just the Ethernet handoff, so by default it's going to go to a broadcast. Those DR/BDRs are more for like situations on the right here, where I have like a campus network that's maybe layer 3 to the access or something like that, right? And it's just for efficiency, so I don't have to form adjacencies everywhere. Everyone is just adjacent to the DR and the BDR, and that's it. And when I have updates, I send my updates to the DR. He multicasts them out to all the other routers participating in the broadcast network. Take a quick break there as I get ready for my lab. Any questions? Nope, doesn't look like it. So we're just gonna, we're actually not setting up this lab. This is just a reminder for me to hop over to my lab. Hopefully I backed everything out. Show IP OSPF neighbor. Yeah, no OSPF. We're just gonna bring up OSPF between two routers, R1 and R2. Everything else is pretty much done for us. You'll see that the IP addressing is already here, right? So this is about as basic as it gets. This is OSPF in a single area. Now, the first thing I do in every single routing protocol is I set a router ID and I do it explicitly. You don't have to do it, but I would highly recommend it. It's pretty mandatory for BGP. It's absolutely recommended for OSPF. It's a nice to have in EIGRP. I just get in the habit. I do it on all my routing protocols and all my routers. I'd recommend you do the same, but that's why I like to do explicitly, so it's not picking one for me, right? And then we can add that network into OSPF. Use inverse masking. And then you send it to an area. And this is a good time for me to point out, this is just Jason is old sort of thing. I do dotted decimal notation for my areas by default. You don't have to. Almost no one does. You can just put in an integer like area 0, right? We'll go ahead and do that. And then let's go ahead. Remember, I'm running in a single area here. And so what was my recommendation in single area OSPF? To use area 0. So we'll use area 0. And we'll add our next interface. And by the way, we are hooked up back to back. So I will also change OSPF network type to be point to point. Right? And if I come over here now to R2, give me a router ID, add a couple of network statements. I have to pause on the network because I'm used to doing dotted decimal. Okay, and then we can use a command like show IP OSPF neighbor. This will tell me the state of my neighbors. We're going to go through neighbor state in a few slides. You can see for it's been up for a little bit and my state is full. That means I have a full neighbor relationship with the other one. I can do things like show IP OSPF interface. This will tell me things like the network type we talked about before, right? So here's my G00 interface, and you can see that the network type has been set to point to point. That's because I changed it, right? And it's telling you that the OSPF cost is 1. Well, why is the cost 1? The cost is 1 because the reference bandwidth is still 100, right? We can change that as well. I'll give you by your hello and dead intervals, right? I can come in to the routing process. There was a question on when did I get my CCNP. I got my CCNP. I can't remember. I think it was 1999. I got my CCNA in 1998. So I got my NP in either 99 or maybe very early in 2000. And then I got my CCAE in 2002. Um, and I didn't get any kind of discount for anything from Lab Gear. We're using Cisco Modeling Labs today for today's demo. There's other options out there like GNS3 or Even G. These days, I would probably look at Even G over GNS3 because it can support a wider variety of images. Um, and like I said, you can get access to Cisco Modeling Labs for free at developer.cisco.com. It does limit you to 4 hours at a time, but once you kind of get the hang of working with the YAML files, that's not as big a limitation as it sounds. You can also buy a personal version of CML for, I think, $99. They don't give you a hard limit that I recall. I have customers who need gear. Oh, yeah, we don't resell used gear or anything like that. Good question, but I can get you a discount on new gear, but reach out to me via email if you'd like to talk a little more about that. For the reference bandwidth now, you can see it's in terms of megabits per second, right? So if I do 100, that's 100 megabits. Of course, we want more than that. So if I do 1,000, that's a gigabit, right? And then that's 10 gigabits. That's 100 gigabits. Let's do the same thing on the other side. Oops. Okay. And now if I do a show IP OSPF interface, and I could do G00, I think. Now you see the cost went from 1 to 100. And that's because I've changed that reference bandwidth, which again, I would always recommend. Okay. I'm going to come back into the slides real quick. I'll just check to see if there's any other questions that I missed. Okay. All right. Oops. Let's talk about those, some area types. There's 3 special types of areas: stub area, totally stub area, and my favorite, the not so stubby area. Stub area is part of the OSPF RFP. It's standards based. All vendors will support stub areas. This will basically, it says the only routes I'll learn are native OSPF routes. So it won't learn about things like redistributed routes. You might think, well, like, how will my default route work then if I can't have redistributed routes? Well, if you think about it, that works because if I don't know how to get somewhere, I will just go to my ABR, right? Which is pretty natural in OSPF to just route through the ABR for something like that. So that's how that kind of works. A totally stubby area is Cisco proprietary, although other vendors have similar compatible features. They may call it something different depending on the vendor. Not all of them may, but it is technically totally stubby area is Cisco proprietary. That being said, I actually prefer totally stubby areas to stub areas. I figure if you're going to limit the number of routes, let's really limit the number of routes. That will only learn the native area routes for the area you're in. If area 2 is a totally stubby area, the only routes when I do a show IP route or show IP route OSPF, the only routes I will see are the native area 2 routes, or what we call the intra area routes. On a routing table, they're represented as O's. If we kind of come back here and do a show IP route OSPF, you'll see I have an O route for the loopback on R2, right? And if we look, you can see an O route is, it just says OSPF. It defaults to really meaning intra area. Inter area, meaning it's still a native OSPF route, but it's from a different area. It would be an IA route. Okay. So a stub area will take O routes and IA routes, but a totally stubby area will only take O routes. And then there's my favorite area, the not so stubby area. This is a stub or totally stub area where you decided to redistribute some routes on that router that's configured for stub or totally stub, which makes it not so stubby, right? It's like I'm a stubby area, except I redistributed these external routes in, but I'm not stubby because we're going to get into the LSA slides in just a minute or two. But those are the three main ones. Not so stubby is also Cisco proprietary. But again, you may find other vendors have similar capabilities. So now we'll hop into the LSAs. This is not an exhaustive list of LSAs, but I think it's exhaustive enough. These are the ones I think you most commonly run across in production OSPF networks. They're called around I've got 3 OSPF networks on my router. I've got G00, G01, and loopback 0 or something like that. Then I would generate 3 type 1 LSAs, 1 per. And you're going to see this behavior again and again with LSA. They typically generate 1 per whatever goes into the LSA, right? So for a type 1, we're putting in our directly attached OSPF interfaces and their respective networks. I will do 1 type 1 per. A type 2 LSA is a lot more specialized. This is per link, as long as that link acts as a transit between 2 OSPF speakers, and it's configured to have a DR-BDR election, meaning it's a broadcast network type, right? So for example, I don't generate a type 2 for my loopbacks because they're not transit. And I don't generate a type 2 for my point-to-point interfaces if they've been configured for point-to-point because I don't elect a DR or a BDR. And then things get a little more interesting. Oops, sorry about that. Things get a little more interesting at type 3. I think it has one of the worst names. They call it the summary LSA, which everyone likes to think that means that this is how I do summarization. It is not. It's what it's really saying is I'm summarizing what is reachable in another area to in one area to another area. So if I look at my drawing up here, I would do a type 3 summary LSA, let's say on R2 from area 0 to area 1 for every OSPF network in area 0. So if there's 10 prefixes in area 0 or something like that, you'll send 10 type 3 summary LSAs, right? It's not a map. Again, it's you only run your SPF algorithm per area. So it's not giving you a map or anything. It's literally just a listing of the network. By the way, thank you for the feedback. I'm glad you're getting something out of this. I was a little worried people were getting tired of the routing topics because I didn't get a great registration for this particular topic, but a great registration for the BGP one. So I'm glad that the people who are attending, I got similar feedback yesterday. So I'm glad the people who are attending are really getting some good stuff out of it. Thank you for the feedback. Um, and 1 second here, why? Okay. Um, so just keep that in mind with your type 3 LSAs. They're sent from one area into another. You do one per network. And it's not a map, it's just a listing. There are a couple of special LSAs. There's one called a default LSA. It's used for things like stub areas and totally stubby areas. Um, and you don't need to generate those for non-OSPF routes because, again, on a stub or totally stub, your only path out is the ABR anyway. So instead, you just follow default through the ABR, right? Um, So these default LSA, type 3 default LSAs, they come in handy with type 5 LSAs, which we're going to get to on the very next slide. Um, so a type 5 LSA, it's called an AS external LSA. This makes sense if we think about it. This is an external autonomous system. In my drawing here, let's take R3, for example. I'm hooked up to an EIGRP network, and I'm redistributing EIGRP routes on R3 into OSPF. Right? Ooh, maybe let's start with the other one first, actually. Let's start with BGP. I'm taking in some BGP routes on R1, and I'm going to redistribute those into OSPF in area 0. That makes R1 an ASBR. We're going to get to R3 in a minute. And just like before, I'm going to generate one type 5 LSA per network that gets redistributed from BGP into OSPF. So if I'm just bringing in a single route, I would generate one type 5 LSA. If I'm bringing in 1,000 routes, I'm going to generate 1,000 type 5 LSAs, right? So I do one per network that gets redistributed in. And more, summarizing information to the other areas, right? So a type 4 says, hey, I just redistributed 30 BGP routes. I just sent you 30 type 5 LSAs. By the way, here's a type 4 that that advertises this interface on R1 as the way in OSPF to reach those external networks that are in another autonomous system. That's why it's called a summary ASBR LSA. It's summarizing how to reach the external autonomous system prefixes via an internal or OSPF interface, right? So it's saying, hey, this interface, maybe it's G0/1 or something like that. Hey, G0/1, that's how you reach those 30 BGP prefixes in this case, right? Um, by the way, now let's rethink about our concept of stubby, totally stubby areas, right? If I have a stub area by default, it only takes type 3, type 1, 2, and 3, I guess, LSAs. That's all it accepts. It will not accept type 5 LSAs. But again, I mentioned we get around that because if I'm a stub area, if I need to get to anything that is other than a type 3, I just do so by saying, hey, your default is to go, your default type 3 LSA is the address of the ABR. Go to your closest ABR and exit that way. What if I'm a stubby area or a totally stubby area, and then I redistribute routes into that stub or totally stubby area? So now we're going to look at R3 and EIGRP. So the stubby or totally stubby, let's take totally stubby as an example. It doesn't allow even type 3 LSAs in. So it definitely doesn't allow type 5 LSAs in. It's just ones and twos. So, and then it does have a summary to get out to the ABR, of course. So how do I deal with when I redistribute into a totally stubby area or a stub area? They're the same from this particular example. I deal with that by creating a brand new LSA type called a type 7. Sometimes I think of it as NAT for LSAs. So what happens is I redistribute EIGRP into OSPF. R3 says, okay, those are type 5 LSAs because I'm redistributing. I just became an ASBR. And then it goes a little further down in the order of operations and it says, hang on a second. I'm a totally stubby area or a stub area. I can't have type 5 LSAs. I reconvert the type 5s to type 7s because that's a Cisco proprietary and OSPF doesn't know what a type 7 LSA is. So it doesn't end up getting affected by the stub or totally stub rules, which block type 3s, right? And your type 7 LSAs will propagate actually through to your ABR. And what does your ABR do? If I think of it as NAT on the ASBR, the ABR basically unnats it and it says, oh, look at all these type 7s that came. Let me go ahead and transfer them back into or transform them back into a type 5. And now let me advertise that type 5 into area 0, which is just a normal area, right? That's why I say sometimes I think of it as almost like a LSA NAT. It's definitely not a NAT. Please don't equate it to NAT, but it has, I think if you're familiar with NAT, you would probably agree it has some NAT-like feel to it. Let me just stop there for a second and see if we've got any questions in it. Okay. What is the reason for adding the loopback network to the router? Oh yeah, that's a great question. Let's come back into my lab. You know what? I better refresh my lab anyway. It becomes kind of a pain in the neck if my routers get timed out. So I think the question was, why am I adding the loopback into the process? So I have a loopback 0 interface on this router, 1.1.1.1 /32. And I add it, technically, I guess I add it in two different ways to the routing process. I add it, one is the router ID, which my assumption is what the question was, probably the question around why would I do that? I like to put in a router ID on every routing protocol because the router ID is used in the hello process when I'm first exchanging information to allow the routers to introduce themselves to one another. It's just kind of baked into the handshake process. And I like to control that because protocols like OSPF and BGP, it's a mandatory part of the protocol that you have a router ID. So if you do not assign one, it will assign one for you. And I don't like that to be a random process because, especially in BGP, but even in some specialized use cases in OSPF, it can lead to instability on your neighbor relationships. And so I find that if I just manually set the router ID, then I take all the guesswork out and I say, I want it to be loopback 0. Now, why do I pick a loopback interface specifically? I pick a loopback interface because it's a software-only interface that never goes down, right? If you had a loopback interface that goes down, you have bigger problems than OSPF on your hands. It's just a dummy interface, kind of like the home address on your Linux box of 127.0.0.1 or something like that. And so it's just this logical interface that never goes down. And so it makes a perfect interface for things like my router process ID. I also use the same thing. I use the same concept of using my loopback for all my SNMP logging, network traffic, network management traffic, because again, it's an interface that never goes down. So if I'm setting up SNMP, for example, I'll always source the SNMP off of loopback 0 so that no matter how many redundant paths I have, it's all going to an interface that's a logical interface that typically will never go down. And so I always will have an SNMP path in there that can then report on other problems, maybe in SNMP or something. Like if I have two WAN links and one of them goes down, I don't want to suddenly say, oh, that router must be down because it was pulling against the interface that went down. If I put it on a loopback, I'll just take the backup path, but I'll still report the first path down. That might have been a long-winded way of explaining that. Hopefully, it made a little sense. Neighbor states, we talked about these earlier in the demo. And again, this is not an exhaustive list, right? Just like the LSA types, that's not an exhaustive list. We didn't cover type 6s, we didn't cover type 8s or type 9s. Same thing, there are more neighbor states than these four, but these are the four that I see the most common when I'm troubleshooting or when I'm looking at things. Two-way, that means I don't have any neighbor relationship yet. This is where I start, is two-way. And two-way just means I have bidirectional communication. I've sent a hello packet and I've received a hello packet, and that's it. We haven't even decided if we're going to become neighbors yet. We've just acknowledged that each other exists. We've shaken hands, but we don't know if we're friends yet, right? That's a two-way. We shook hands, but we don't know if we're friends yet. Xstart, this is only on a broadcast network, but it means that I've successfully elected a DR and a BDR. Loading, this means that I've gone past things like two-way and Xstart, and now I'm actually exchanging those LSAs back and forth, right? So it might be like type 1s and type 2s. Type 2s if you're on a broadcast network. Type 1s for sure for per link, right? And I'm grabbing all those LSAs and I'm starting now to build out my map. Those LSAs, by the way, get conglomerated into a thing called a link state database, or the LSDB. You don't need to memorize that, although you might want to. We'll talk a little bit about the link state database and a little bit towards the end when I do the second demo. So that's the loading phase. I'm actually not a full neighbor yet, but I'm getting pretty close when I get to loading, right? And then full, that means everything's good. I've built my map. I've run my Dijkstra algorithm. I know where all my intra-area paths are, and I've built my shortest path tree to figure out how to get to them. Those are the four neighbor states I mostly focus on. So if you're like studying for a cert, you want to study all the LSA types. You want to study all the neighbor states. If you're trying to be practical about it, you really want to know for LSAs your 1s, 2s, 4s, 5s, and 7s. And for neighbor states, you really want to know your two-way Xstart loading in full. Let's talk about route filtering. Now, if you were in either of the previous talks where we covered EIGRP or where we covered BGP, you're going to see a big difference between route filtering in those protocols and route filtering in OSPF. And I'll bluff it for you, bottom line up front, OSPF does not have great filtering capability. You can filter in OSPF. The only place you can reliably filter is at the ASPR or the ABR. The ASBR is pretty obvious. I can just write a filter when I redistribute from one protocol into another. If I only want to allow in 192.168 networks, and I don't want to allow in 10 dot networks because maybe they conflict with my own addressing space. Maybe we bought another company or I'm doing business with another company or something like that. I can just write that as part of my filter via a prefix list. And we're going to go through a redistribution exercise in a slide or two. The ABR, I can also filter. What that does, by the way, is it does not generate a type 3 LSA for that prefix. Remember, there's a type 3 generated per network. So if I filter on the ABR, I can exclude sending a specific type 3 LSA or multiple specific type 3 LSAs so that I can effectively truly filter out that route, right? That prefix. It probably isn't too much of a surprise that I can filter on an ABR and an ASBR only. Does that mean I cannot filter on an area router, a router who all of their interfaces are in a single area, for example? You can do what I call a pseudo filter. You can write a distribute list. It does not truly filter. What it does is you will still have all the LSAs. You will still have a coherent database with all the networks in it. However, the IP routing table is built off of that linked state database, and I can filter out a route from going into the IP routing table. But that route will remain in the OSPF database, and it will continue to be propagated downstream, right? And that means you could end up in weird situations where I filter out 10.1.1.0/24 on R2, but my neighbor R3 installs 10.1.1.0/24 because I didn't write the filter is only locally significant on the router that I wrote the distribute list on. The LSA still continues to propagate. I don't have, and it makes sense. If you really just think about it, it makes a lot of sense. When we talk about within an area, I'm talking about my true link state router how to get to it. Shouldn't be filtering out any prefixes whatsoever within an area. That's why we do our filtering usually on the ABR. So I don't even generate an LSA for that prefix into the area, right? So you can kind of pseudo do it with a distribute list. It's unreliable, it's crude. I would recommend you not do it because it's not truly filtered and it can still propagate everywhere downstream. So you'd have to end up, if you truly didn't want that to come in and for some reason you couldn't write it on an ABR, you'd have to go to every single router and write a distribute list or something. By the way, on the ABR, you use a command called filter list, which is what blocks, when you write the filter list, it blocks the type 3 LSA from being generated. Okay, so let's take a look at this route filtering. We're going to do the second lab now. I'm going to switch over to here. Okay, so this lab is a little bit different. I have OSPF running everywhere, and I have EIGRP running everywhere. You can see R3. R3 is my ASBR. It's also an ABR. Oops. Right? So if I come over to R3 and I do a show IP route OSPF, you'll see that I have some OSPF routes. You'll see that they're all IA routes. It says OIA. O means it's a native OSPF route. IA means it's inter-area. If it's just an O, it would be intra-area, right? I can also do a show IP route EIGRP. And you can see I have 3 EIGRP routes. However, if I come downstream to R2, I do a show IP route. You'll see I don't have any external routes. I don't have any EIGRP routes. I have an O route, I have another O route, and that's about it, right? Um, Likewise, if I come down here, show IP route, we'll see the exact same thing. I have some IA routes, right? But I don't have any external routes. So let's come back to R3 and do our redistribution, right? So again, just as a reminder, here's R3. I'm going to turn it now. It's not an ASBR yet because I haven't redistributed yet. Let's go ahead and do it. It's hard for me to talk and configure at the same time, but I will try to explain what I'm doing here. I like to do my redistribution with prefix lists and route maps. You don't have to do that, but I do. And I like to name them something that's very obvious. I call it the 2 a.m. test, meaning if a network engineer gets called at 2 a.m. to troubleshoot something, can they look at the title on an ACL or a prefix list or a route map or an interface, and even in their sleep deprived state at 2 a.m., they can make sense of it. So I'll say EIGRP into OSPF. To me, that passes the 2 a.m. test. I feel like most engineers on a prefix to say, oh, I'm probably enumerating my EIGRP networks that I'm going to allow into OSPF. And then we'll create a route map. And I typically make my route map have the same name as my prefix list. If that name worked to pass the 2 a.m. test before, why not use it? Okay. In a minute, we're going to come back and revisit this lab to talk about external routes. But for right now, this is just showing how these are going to propagate. Oh, before we do that, I should have. Let's come down here to R1, for example. Let's take a look at the OSPF database. Show IP OSPF database. So it's got a pretty simple database, right? So remember that the type 3 LSA is called a summary LSA. These are my type 3s down here. And it's telling you what router I learned them from, right? Now let's come on back and let's go into oops. And unlike EIGRP, OSPF is not a lightning fast protocol. It might take a minute, might not. Oh, no, they're there already. You can now see a big difference. I've now added in my type 5 links, right? So hopefully that makes some sense, right? By the way, you can do things like show IP OSPF database external just to see your type 5s, right? And this will give you some extended information. We're going to talk about some of that extended information right now. So we just did a redistribution lab, but we didn't talk yet about how OSPF deals with redistributed routes. And I mentioned before, I think that OSPF is pretty weak at filtering because I can only filter on the ABR and ASBR, whereas in something like EIGRP, I can filter on any router I want, and it takes effect across my entire autonomous system. However, where OSPF makes up for this in spades is on redistribution and how it deals with external routes. It actually does things a little differently than any other protocol. When you redistribute from OSPF or from another protocol into OSPF, you have two options. There's two types of external routes, a type 1 and a type 2. And they have very key differences. A type 1, you bring it in with some kind of a default cost, let's say a cost of 100. So I do like a redistribution from EIGRP into OSPF, and I'll say, by the way, the cost is 100. Once I do that and I set the type to be type 1, after it's redistributed, it adheres to the OSPF algorithm, right? So if it comes in with a default cost of 100 and then it traverses a link that has a cost of 10, and then it traverses another link that has a cost of 1, it will show up with a total cost of 111. It took the initial 100, it added the cost of 10, and it added the cost of 1 to get 111. As opposed to a type 2, where it comes in again with a default cost. We're just going to use 100 as an example, and it never changes that cost. It comes in at 100, and whether it crosses a 10 and a 1, or whether it crosses 5 10s and 5 1s, it still always has a cost of 100, meaning it ignores the SPF costing mechanism after it's been introduced. Because of this, a type 1 will always be preferred over a type 2. However, the default redistribution is a type 2. Hopefully that makes some sense. Does anyone have any questions? Yeah, we got a question coming in here. Give me just a second. Ah, that's a good question. Brand, that's a very good question. No, because I didn't do the redistribution bidirectionally, which is really just I just was a little bit lazy. We could do that though. We could do that if we did something like so I'd have to do the same thing in reverse, right? Like OSPF into EIGRP. I'm actually not going to do this because I can't remember all the routes I have set up, but I would have to redistribute from OSPF into EIGRP. When I redistribute, I always use prefix lists to explicitly control what I am allowing in. And when you use a route map, it's similar to an access control list in that anything that's not explicitly permitted is implicitly denied, right? And so if it's not in my prefix list, which is matched in my route map, it's not going to go through the redistribution. This is important because the last thing you want to do is accidentally feed back routes to in this case, EIGRP. I wouldn't want to just say, hey, take everything in OSPF and dump it into EIGRP, because EIGRP then might say, oh, look, they also have 192.168 networks. Instead, I would say something like, only take these OSPF networks and redistribute them in. But let's come back here. Get a little space here. Let's look at these external routes, right? So you can see that it says the metric type is 2, meaning it's a type 2 external route. Remember I said it's the default type, right? And it has a cost of 20, right? And it tells you metric type of 2 means larger than any link state path, right? That's what I mean by it will always prefer type 1 over type 2, because type 2 by definition, it doesn't adhere to the link state protocol, right, for costing. And so we didn't do anything. Right? We didn't do anything to set metric or metric type. And so it just took the defaults, which is a type 2, right? By the way, if we take a look over here, you will see that these indeed come in as O, E2. O meaning OSPF, E2 meaning OSPF external type 2 route. So here's the magic of route maps. Let's go ahead and come on in here. Let's come into my route map. And now let's set metric. Instead of 20, let's go with 66 because 6 is my favorite number. And let's set metric type to be a type 1. Right? So now we should see a difference when we come back to R1, right? Remember before it had metric type of 2, larger than a link state path, and a metric of 20. This might take a second to update. Let's see. Oh, look at that. It's already done it. Metric type of 1, right? Comparable directly to link state metric. I don't know why it's, oh, I think this is saying that it came in with a metric of 66. If I do a show IP route, what is that? 192.168.1.0. What does it say the cost is? It says that the cost is 68. Yeah, I see. So this is saying really, hey, because I'm looking at the database, that makes sense now that I think about it, right? On this type 5, it's basically saying it's a LSA type 5. It's a metric type of 1, type 1 external, right? Meaning it's comparable to the link state metric. And it was introduced with a metric of 66, and it won't change, or it will change. And you can see that because when I do an IP route and I look at the cost, you can see it's gone from 66, which is what I redistributed it as, to 68. Why is that? It's because I didn't change the reference bandwidth in this particular lab. I'm kind of running two different labs in parallel here, right? So hopefully that made some sense. Let's go ahead and wrap this up. And again, I think that OSPF, the way it deals with external routes, I think it's just the most elegant way to deal with it. Let's look at it in contrast to EIGRP. EIGRP, what is its mechanism for dealing with external routes? It uses administrative distance. That's kind of a nuclear option. And it doesn't even use a small tweak of administrative distance. It's 90 or it's 170. That's just, again, it's kind of a nuclear option. I'm not a fan of it, right? I love the type 1, type 2 concept. And think about it this way. If you had, let's say, default route, and it's coming in through path 1 and path 2, but let's say path 1 is an Ethernet handoff from my ISP, and path 2 is maybe an LTE handoff from a different ISP, but I pay for my bandwidth utilization on path 2. Well, then I should probably redistribute default as a type 1 external on path 1 and a type 2 external on path 2. So I will never send my internet traffic down that LTE unless I have a failure on my Ethernet handoff from my ISP, right? That's a very elegant way of dealing with that. I just say, hey, type 1 here, type 2 here. I always prefer type 1 over type 2. And you're kind of set, you know. So again, it's something I'm a big fan of. I love the way OSPF deals with these external routes. I've probably gone on too long already. If you didn't think I was nerdy before, you certainly think I'm nerdy now. That's okay. I've been that way all my life. So last slide, I think here we're just gonna, or last couple of slides, last topic is summarization. This should now not come as a surprise. Where do we do our summarization? Well, we do our summarization on ABRs or ASBRs. Kind of makes sense when we think about it, right? So for example, here, let's summarize on the ABR. In one of my OSPF areas, let's say area 1, maybe, I have 172.17.00 /24, and then 172.17.1, 172.17.2, 172.17.3. And I want to take those 4 routes and just summarize them as a single /22, 172.17.00 /22. Here's an interesting question. I've got 3 prefixes on 3 different routers, all with different costs. What cost does that single /22 in area 0 show up as? Does anyone have any guesses? It's okay if you don't, but I'll pause for a second to see if anyone has any guesses on what the cost would be. No guesses? Okay. It will show up with whatever the lowest cost of any one of those 4 prefixes is. So if, for example, I had a cost of 100, 100, 100, and then a cost of 1, then the /22 shows up with the cost of 1. Now, it's an OSPF route, so of course, the more routers it hops in that new area 0 in this case, it will add to the cost of 1. It's not like an external route, but it is kind of interesting, and you should just be a little aware of it. Just cognizant of it, really. It's not breaking or hurting anything. The way that we summarize on an ABR is we use the area range command. So I say area, what area am I trying to summarize for? In this case, area 1. And then range, and then what's my summary network? In this case, 172.17.00 with a /22 mask, right? And then what that does is it says, hey, in area 0, summarize area 1 as this single entry. Now, you'll note that for area 1, I've also got a bunch of 10 networks in here. Those will still go through. This is not saying I'm going to drop everything that doesn't fall in my summary range. It just means everything that is in that summary range, send it as a single route instead of multiple routes. Make sense? What about at an ASBR? It's a little more straightforward to do summarization on an ASBR. I've got my external routes, right? And I just use a command summary-address, right? Just remember, if I'm summarizing type 3 LSAs, that means type 3 LSAs get generated where? They get generated on the ABR. So if I'm summarizing type 3 LSAs, I'm going to use the area range command. If I'm summarizing type 5 LSAs, right, where do type 5 LSAs get generated? They get generated on the ASBR. Then I use the summary-address command. Make sense? Okay, that's it. I did want to share with you, like I said, when probably tomorrow, I will have everything sent out to you. But I'm going to include a little goodie this time, which is an OSPF challenge that I wrote up. And so anyone who registers, even if they don't attend, will get access to this stuff. We're always trying to get more people to join, so please help us spread the word. That's the only way a user group really stays vibrant enough to be maintainable, is by getting, the word out to people. We never, there's no charging of fees, there's no sales, there's no nothing. Again, it's just something that's led by engineers for engineers, right? This has like 17 or 18 written questions on it. I'll go kind of fast because this is one that's actually already been finished. And then it has a whole lab section. You don't have to do it. You could take this and throw it away if you want. I'm not gonna, it's not gonna hurt my feelings at all. But if you would like to, I love OSPF. I've been using OSPF almost, I can't say exclusively, but it's been my predominant routing protocol since about 2001. I started a large enterprise networking project in 2001, and I really fell in love with OSPF. I still probably prefer BGP, but OSPF is a great routing protocol, and I use it quite literally every day. I was configuring OSPF today, and BGP for that matter. But I'll send this by as well. You can ignore it, or you could play around with it. I'm not grading anything here, right? So it's up to you.
Need help? Call our cybersecurity team and book a consultation with us today.